Welcome back to our podcast today. And we got a topic of interest that combines together some interesting technology and some interesting industrial aspects as well. We have Ian Skerrett with us today, and he's got an interesting background between manufacturing, the Internet of Things, and open source. And Ian, I've got to ask in the sense that we certainly understand the play of software and the Internet of Things and manufacturing. There's so much going on in manufacturing. For example, the metrics that are coming out of manufacturing to look for improvements along those lines. We understand the Internet of Things. There's going to be software at each one of the endpoints, and there's whole issues there as to where the data and the analytics take place. Does it take place at the endpoint, or is that uploaded to the cloud itself?
Sure.
But open source software, how does that fit into this equation? Because you're making this kind of a triangle now between the manufacturing as well as the Internet of Things. How does open source fit into that? What problems does it solve?
Well, I think open source it's kind of a reflection of the entire software industry, where open source software, like there's a famous quote, kind of, software is eating the world, and I would contend that open source software is eating the software industry, where a lot of the base fundamental software that's being created now is open source. Right, that it's a very proven, effective method of developing core technology and kind of having adoption of core technology. And if you think about kind of the internet itself, right, that the internet itself was created based on open standards and open source. Like I'll often say that if Tim Berners-Lee took some of his creations and patented them and moved to Silicon Valley and created a startup around his patents, right, we probably wouldn't have the internet that we have today. And I think that's a really important philosophical kind of discussion to have with when you talk about IoT, that if you really want an internet of things, you need to start learning about kind of how you get this interoperability, how you get a base set of technology that everyone's using to have a true Internet of Things. And I think open source basically provides a mechanism of providing the kind of some core fundamental technology that everyone's using to build IoT solutions. So, like for instance, I think kind of connectivity, like how do you connect devices to a cloud solution? Right? There's certain protocols that are in place. The implementation of those protocols, something like MQTT or CoAP, right? No one's going to benefit from a commercial implementation. That's not a differentiation that a customer is going to value, right? So that's well suited for something like an open source implementation.
Now, when I think of open source, I think back to the day when open source was software that people shared amongst themselves. And it's come a long way from then. We now have all kinds of repositories out there that are maintained by large communities, and the software itself is much more stable and I suspect evolves quicker than proprietary software. But I still tend to think of open source software as software that's solving a common problem. So somewhere in the industry, somebody says that this is a problem that many different organizations or people have, and software gets developed around that, as opposed to software which is very focused or niche oriented. And I'm kind of imagining in the Internet of Things that there's going to be a combination of both. There's going to be some common problems that have to be solved as we connect together the refrigerator and the toaster and other things. But there's also going to be the potential for niche software in there. Maybe the toaster has some special needs that the refrigerator doesn't. So are you seeing both kinds of software being developed, or is it more just the software for the common types of problems which are inherent in the Internet of Things?
I think that the starting point is always kind of the common type of problems, and that's where I see most of the open source activity around IoT today. So a lot of common IoT architectures, as an example, a lot of common IoT architectures will have some type of gateway And the gateway, it kind of performs two functions. One is take the connectivity of the different sensors and actuators and aggregate that into a common point that then connects to some type of network, whether it's a cellular, whether it's just an IP, like kind of Ethernet. And so that gateway, right, itself, right, it's very common that everyone typically needs it. And so that's where you start to see projects like Eclipse Cura or the EdgeX project that's just started, really kind of performing and producing software to meet that requirement. Right. So, but I think I agree. Like that, there's always room for commercial software, and I'm a big believer that open source and commercial software are symbiotic, that you need kind of companies making commercial profit, because that's how you get the investment back into the open source community. And I think you will always see kind of vertical applications that are commercial, that are built on top of open source, but kind of the vertical solution is often commercial. There's going to be examples where vertical applications are open sourced in IoT, but I haven't seen that yet.
Now, Ian, you're also very active on social media, and you've got a blog post on WordPress, and I was looking at that recently, and it talks about IoT, Internet of Things, in the manufacturing sphere. And can you give us a sense of some of the applications that are taking place there? Are you looking at the connection between different kinds of devices? Are you looking at something around the metrics or the activation side of sensors? What's going on there?
Well, I think in the manufacturing industry, and there's lots of people call it Industry 4.0. It's kind of at a high level, the business drivers is how do you bring together the operational technology, so that the technology that's being used on the factory floor, with the IT, so the kind of the ERP system, the supply chain management systems, the back end enterprise systems. Right now, there's a big kind of divide, and the business requirements, though, for the manufacturing is how do you get to kind of like a mass customization of a factory floor, kind of a factory run. So they'll use the term lot size one, right? It's very expensive to set up a factory line, and so but the market requirements is to get kind of a lot of customization around products, right? So how do you get a flexible manufacturing process that can take the demands coming in from your CRM systems, right, and market planning systems, and kind of feed it into the factory floor, right? So that kind of connectivity is as an example of the drivers. The flip side too is that also in terms of downtime, right? If a factory goes down because a machine broke, right, that is a huge interruption to the business, right? And so how do you, from a kind of predictive maintenance, right, how do you start to predict when machinery is going to break? And if you can predict it's going to break before it breaks, then you can fix it, right? And so that's where a lot of the analytics will come in too, for taking the sensor data off the machine, and analyzing and looking for faults, looking for patterns that say, okay, yeah, this machine's going to break. We need to replace this type of part. So those are kind of some of the big drivers you see in manufacturing that's going on today.
And this should create quite a change in the manufacturing space if we can analyze that kind of sensor data that's coming out, and as you say, have that predictive capability. And particularly if that predictive capability reduces or brings down the level of uncertainty as to where the machine is going. So if we just have a human operator, they can be looking at the machine and say, maybe I think this is what's going to happen in the next 24 hours, but there's a large factor of uncertainty in their estimates. And I can imagine in manufacturing that reducing that level of uncertainty around forecasting is quite significant.
Yeah, for sure, right? And because downtime in a factory is a huge issue for the whole supply chain, for meeting the market requirements, right? So anything they can do to lessen that. And there's also a safety thing too, right? That you talked about, kind of the human interaction, right? Well, like safety is a huge concern on factory floors, right? So if you can improve your safety record by making sure machines don't break and hurt people, that's a huge issue for them to address too, right? So there's a number of kind of good business reasons to invest in this area. The challenge though is that it's not trivial, right? To implement these things, because there's a lot of investment in factories. The equipment, the technology used in factories is often decades old. So kind of connecting things to the internet, right? Existing machinery to the internet is just kind of not plausible, right? The best is kind of a PLC will have some type of port on it that you can start sniffing to kind of take the information off and then start to try and understand it. So there's kind of the whole brownfield versus greenfield discussion too, right? Where the brownfields are the existing factories, and then how do you modernize that, and how do you bring in this technology and not disrupt the existing flow of the factory floor?
Well, based on what you were saying there, Ian, I've got two questions. One is around that safety aspect, but the other is this connectivity between the legacy machines and the internet potential. How does open source software have an advantage in this connectivity of the older style machines? Is it that the software is written in a different way than the proprietary? What's the advantage of using open source with legacy machines?
Well, there's probably a couple, and like to me, open source is just a way of developing software. So it's a more modern way of developing software. So I don't think it's kind of hugely different than a proprietary approach. But I think what it does is allows you to share in the implementation, share in the feedback around the implementation. So in kind of the manufacturing setting, there's a standard called OPC-UN, which is a standard that's getting pretty good adoption in the manufacturing area. And this is kind of how machines communicate to each other and to kind of communicate their status. So there's implementation. So the OPC Foundation has open source implementations of their protocols. There's other open source implementations. Eclipse has one called Milo. And so people can go and take these, they do proof of concepts, do experimentation with setting up IoT systems in their manufacturing setting. And they can go to production if they want, or they can get a production, like a commercial solution too. So open source provides a way to do really easy proof of concepts in this setting that can go to production, or if you want to go to a vendor that kind of does the service and support around it, you can kind of take your proof of concept and kind of start to approach different vendors for that.
And just to clarify, when you were mentioning Eclipse, you were mentioning the Eclipse Foundation, which is a repository of open source code. The other question I wanted to ask you, Ian, was when you were mentioning safety, and you were specifically mentioning safety in the manufacturing environment. But if we take safety to the Internet of Things in a broader context, and we think, for example, of moving things such as automobiles or even toasters, there is as we move to the Internet of Things, there is a safety issue. The security issue becomes a safety issue in that if these devices are taken over by an external party, then there's a safety issue related to the security issue. How does open source interact or speak to the safety issue? Is it, because if we think of open source software, there's a repository, as you're well aware of the software. Maybe it's possible that someone could put in malicious code in there so that they could have a backdoor into the software that's used in an automobile. How is that being addressed in the industry?
So any professionally run open source projects will have a development process and a commit process that protects against that. So kind of let's back up a bit on some basics around open source software projects. So first of all, most kind of high profile, most production ready kind of open source projects are run by professional developers. They're paid by different companies to do the open source work, right? So it's open source, successful open source projects aren't a bunch of guys kind of working part-time in their basement on it. It's like the world is very much, this is a professionally run kind of development process in community. And then all, if not all, most open source projects will have a process where there's a core set of committers that have the right access to the kind of the Git repository, the code management repository, right? And so there's a name set of people that can actually put code into the repository. Anyone can make suggestions, right? Which in the Git terminology would be a pull request. So anyone can say, here's some code that I think would be great to put into this repository, into this project, but only the core committers can actually accept those requests, right? So it would be very difficult for some unknown person to get code into any professionally managed open source project, right? Because there's a process around how code gets changed.
Okay, now let's talk about the Internet of Things in general, and is there open source software being used in let's say, the automobile? I know that there's a number of companies that are looking at providing operating systems and doing data analytics on all the sensor data information that's coming out of the automobiles. So how is the open source playing in that area?
So if you are doing data analytics, you're probably doing some type of big data database around Hadoop or Cassandra, which are all open source.
Right.
If you're doing time series data analysis or time series storage, you're probably using something like InfluxDB, which is open source, right? So any data store used in IoT for doing analytics is going to be open source. Even kind of getting into dashboarding, right? There's a project called Grafana, right, which works really well on time series database, right? And that's open source, right? So kind of in general, analytics is that whole area is completely dominated by open source. If you go into machine learning, like TensorFlow is the big technology of machine learning, that's all open source, right? So that's predominantly open source. On the cars, right? So there's two sides of a car. There's the software running. Well, there's kind of software running on the car. There's two types of software, right? There's the software that controls the brakes. I forget the term off the top of my head, right? But the kind of safety critical systems, kind of the brakes, the transmission, stuff like that. And then there's the multimedia software, right? And my understanding, I'm not an expert in car software, but my understanding is those two types of software are kind of treated quite differently. There's an operating system, and I'm drawing a blank here. There's a Linux-based operating system that's being developed by a number of car manufacturers in open source. It's a derivative of a distro of Linux, which is open source for car operating systems. I don't certainly on the analytics on the back end, there's a ton of open source, and I don't have enough experience to say specifically what's going on to the car, but I know there's work to be done certainly on the operating system level. Thank
you, Ian. As we close our podcast for the day, I'd like to ask for a couple of takeaways from yourself in this interesting combination of the Internet of Things and open source software. And we have a number of different kinds of individuals that listen to the podcast. Some are in the academic area, perhaps they're teaching technology or they're teaching business courses or other courses or they're doing research in the technology or manufacturing area. We also have business practitioners who might be an executive in an organization that's looking at open source software, and they're wondering what are some of the concerns that they should be thinking about, what are some of the places that they could look for more information, what are the questions that they should be asking the IT people. Have you got any suggestions for them as takeaways?
Sure. Well, I think for the academics, what I'd say, like, this is an incredibly exciting time for students, and for teaching students, and for even developers to learn, right? Because it's so easy to go out and buy a Raspberry Pi, or go out and buy an Arduino. There's tons of sensors that you can buy quite cheaply, get them delivered really quickly. And so it's a great opportunity just to learn and just to play around for really kind of innovation, right? And so I think for academics and even developers, what I always encourage is, like, just start playing around with things. It's really cheap to do that now, right? And it never used to be, right? But open source makes it really easy to use, and the open hardware movement, or kind of what's really accessible hardware, it really makes it easy to go and get an embedded board now, and you can download the software because it's free and open source, right? And you can just start building stuff, right? So I think take that opportunity and do that. I think for concerns around open source for kind of business executives, I guess there's a couple of things. One is, I would contend that you're already using open source today, right? That the software industry runs on open source. The internet runs on open source. So I think it's an old thought process that open source isn't safe, right? Because it really is dominating the software industry today. I would encourage people that if you're looking at kind of selecting an open source project to use internally, that look at kind of who's behind it, right? Is it with an open source foundation? Is it with a reputable open source foundation? Because you want to make sure it's not just one company that's dominating and owning an open source project. You want to see diversity there. And there's a number of really good open source foundations, like the Eclipse Foundation, Apache Foundation, Linux Foundation, right, that are hosting these open source projects and provide the governance that, from a business point of view, you want to see to make sure you're protecting your investment in that technology.
Okay, so we've come to the end of our podcast today. I want to thank you, Ian, for giving us not only that insight into this interesting area that's emerging, this interesting combination between open source and the Internet of Things and its application in areas such as vehicles and manufacturing, but also those takeaways. So thank you very much for that.
Well, thanks for having me.
Good. And that ends our podcast for today. Don't forget to join us again for future podcasts. My name is James Bowen, and we've been speaking with Ian. And that's it. Good night.